Good morning, guys. Today is April 17th, and we're going to be doing right triangle trigonometry today. This is going to be a lot of review from last year in Math 2, okay? One thing, if you look at this, this is a right triangle, and we know it's a right triangle because we have a right angle here. This side right here is called the hypotenuse, okay? So that's going to be really important, all right, that you can always identify which side's the hypotenuse. It's the side that's always opposite the 90-degree angle. And a lot of times we'll call this angle C, and then this is little c, okay? So the side opposite is a lowercase letter, okay? So angle C, little lowercase c for the side length, okay? Capital C for the angle, lowercase for the side, okay? So this is the hypotenuse, okay? And then right here at A, at angle A, right, we're also calling it theta, okay? The side that's opposite is a leg. Now, this leg has a specific name. If we're talking about in reference to this angle theta or angle A, this lowercase a, little a, is the opposite leg. Okay, so I'm going to label this opposite leg. Okay, and this is also a leg, but it's called the adjacent leg. So it's adjacent to the angle. Now there's two sides that are adjacent, but this one's the hypotenuse. Okay, and this one's the adjacent leg. So there's a difference between legs and hypotenuse. Hypotenuse is always opposite the 90-degree angle. Okay, so this is the adjacent leg. Okay, now if we're at angle B, the hypotenuse is still the hypotenuse. Okay, but now if we're at angle B, this side over here is now the opposite leg, and now this leg becomes the adjacent leg. So the opposite leg and the adjacent leg are always in reference to the angle we're talking about, and we'll be talking about either angle B up here or angle A down here. Okay, all right, a few more things that we need to go over. Okay, we need to remember the Pythagorean theorem that if we take a leg, which we call a here, so a squared plus leg squared, in this case it'd be b, that's always equal to the hypotenuse of the right triangle, which is c squared. Okay, so leg squared plus leg squared is always equal to the hypotenuse squared. Okay, so one other thing we need to do, and you're going to see some of these side lengths are going to come out to be square roots. Okay, so we're going to need to know how to square something like this: 5 square roots of 2 squared. Okay, this really means in here 5 times the square root of 2. And using exponent rules, what we could do is we could rewrite this. This would be 5 squared times the square root of 2 squared. Okay, so what's 5 squared? Well, 5 squared is 25, and the square root of 2 squared, those undo each other. Okay, so you're going to be left with just 2, and 25 times 2 is 50. All right, so 5 square roots of 2 squared is 50. Okay, a few other things that we need to talk about is the 3 trig functions that you know right now. Okay, so right now, we know that from last year in Math 2, that sine of angle theta, so we're talking about this angle right here, all right? Sine of theta is always the opposite leg over divided by the hypotenuse. Okay, so in our example here, for angle theta right here, okay, the opposite leg is lowercase a, and the hypotenuse is c. So this would be a over c. Okay, cosine of angle theta is defined as the adjacent leg over the hypotenuse. I wish I could write faster. Okay, and okay, so then that would be the adjacent leg for angle theta. The adjacent leg is the leg that's next to it, which would be b over the hypotenuse, which is c. And there's a third trig function, which is tangent of theta. So tan theta, okay? And that's equal to, that's defined as the opposite leg over the adjacent leg, okay? So the opposite leg over the adjacent leg. Okay, and in this case, that would be the opposite leg is A and the adjacent leg is B. So this would be A over B, lowercase a over lowercase b. Okay. Now, some Math 2 teachers teach you guys this. I know I did with my Math 2 class last year, but there's a way to remember these, okay? And it's SOHCAHTOA. And so that's spelled S-O-H, okay? And that represents sine is opposite over hypotenuse, okay? And then CAH, C-A-H, and that represents cosine is the adjacent over the hypotenuse. And then TOA, SOHCAHTOA. So when you stub your toe, you soak your toa. Okay. So that was corny, I know. All right. So tangent is the opposite leg over the adjacent leg. So SOHCAHTOA is a way to remember these relationships. Okay. Now, in a few days, okay, what we're going to do is there's 3 more trig functions. And those 3 trig functions, all they are the reciprocal of all of these. So it's going to be hypotenuse over opposite leg and hypotenuse over adjacent leg and adjacent leg over the opposite leg, okay? And that's coming up. And so there's 3 more trig functions that you guys don't know about yet, okay? All right, so that's everything that you need to know to really complete all of the problems today, okay? So now we're just gonna get into some problems and work some problems out and show you what I expect to see, okay? All right, so let's go to the example number 1 for the first one. Okay, so for this first example, we wanna find the value of sine of theta, cosine of theta, and tan theta for the given information here. And we have a right triangle, so let's start labeling some stuff, okay? So we know that this is my right angle, so this would have to be the hypotenuse. I would always identify the hypotenuse first, okay? Here's my angle theta, okay? So then this 6 right here, this side length that's 6, has to be my opposite leg, because this is a leg, but it's the opposite leg, okay? So I'm just gonna put OPP for opposite, okay? And then what that means is we're missing this adjacent leg right here, okay? All right, so I'm gonna label it with a variable, okay? And right now it's vertical, right? So I'm gonna call that one Y, okay? Just because it's vertical. You can call it any letter you want, all right? All right, so I know from Pythagorean theorem, I'm gonna be able to figure this one out because I need this to know all 3 trig ratios, okay? So to figure out Y, I know that this is gonna be 6 squared plus Y squared would equal my hypotenuse, which is 10 squared. Okay, so that would be 36 plus Y squared is equal to 100. I'm gonna subtract 36, and that would give me Y squared is equal to 64. I'm gonna square root both sides, okay? Okay, now this gives me the absolute value of Y, right? Okay, so the absolute value of Y would equal 8, which means Y is equal to plus or minus 8. All right, but this is a triangle, so it can't be the negative one. It has to be the positive one. So it's just Y is equal to 8, okay? So now I know this side length is 8, okay? And now because I know this side length is 8, I can do all 3 trig ratios, okay? So sine of angle theta, and that's what we need to write. We need to write sine of theta, okay, is the opposite over the hypotenuse. So that'd be 6 over 10. Now this ratio reduces because they're both even numbers, right? So they're both divisible by 2. And so that becomes 3 over 5. And then cosine of angle theta. Well, okay, so cosine's the adjacent. So the adjacent leg to angle theta would be the y, which would be 8, over the hypotenuse, which would be 10. And those are both even numbers, so they reduce again. So this becomes 4/5, okay? And then tan of theta is the opposite over the adjacent, okay? So the opposite is 6 and the adjacent is 8. So this would be 6 over 8. And then both those are even, so that reduces again, right? So this becomes 3 over 4, or 3/4. Okay. Something I didn't do, and I wish I had this right here, and I started to do it and I didn't. Okay. This leg right here, let's label adjacent. Okay. So for this angle theta, this is the hypotenuse. That's the opposite leg. This is the adjacent leg. Hypotenuse will never change. It's always going to be opposite the 90-degree angle. Depending on where angle theta is, this could be the opposite or the adjacent, because if theta was up here, now this one would be the adjacent and this one would be the opposite. Okay, so opposite and adjacent change depending on where that angle theta is and which angle I'm talking about. Okay, all right, let's go to example number 2. Okay, so for example 2, I've told you that cosine of angle theta is equal to 1 over 3. And I want us to be able to find tan theta and sine theta, okay? So what I would encourage you to do is to draw a diagram for this, okay? All right, let me get my other pen. All right, so I'm gonna draw a right triangle. And this doesn't have to be the perfect size or anything. It's just a right triangle. So there's my right angle, okay? I'm gonna put this angle theta, I'm gonna put it right here. Okay, the bottom of the right triangle here. Okay, now what do I know about cosine of theta? Okay, cosine of theta, this has to be the adjacent leg because the definition of what cosine theta is, and this 3 has to be the hypotenuse. So that means I'm going to put the 3 where the hypotenuse is. Well, that's right here. Okay, now this is the adjacent leg. And so the adjacent leg, these are my 2 legs. Okay, this leg right here, because the angle theta is right here, this leg right here is the opposite leg. So this leg right here that's next to angle theta, this leg that's next to the angle has to be my adjacent leg, which is 1. Okay, now again, we're missing this side right here, right? So we're going to label that. Okay, let's label it Y. Okay, you're going to see me, because we're going to do this later on, the vertical ones are always going to be Y and the horizontal ones are going to be X. Okay, you'll understand why later on. Okay, I'm actually starting something with you guys, and just kind of planting the seed by doing it that way. Okay, all right, so we got to figure out this Y, right? Well, let's label this. This is the adjacent, right? And this is the hypotenuse, and this is the opposite. Okay, all right. So, and I started doing this last year in my math too, where I had people label which one's the hypotenuse, which one's the adjacent, which one's the opposite. They did really good. My math 2 students did really good on trigonometry last year. Okay. All right. So to get this Y, we need to use the Pythagorean theorem. Okay. So we have 1 squared plus Y squared is equal to 3 squared. Okay. So that'd be 1 plus Y squared is equal to 9. Subtracting 1, that would give me Y squared is equal to 8. And then I'm going to square root both sides. Okay, and this is going to be Y is equal to the square root of 8. Now, we need to simplify this, okay? So the biggest square that goes into 8 is 4. So this is the square root of 4 times 2, because 4 times 2 is 8, and this is a perfect square, so I'm going to be able to square root it. So this Y, okay, becomes, and I should have put plus or minus here. And this would be 2 square roots of 2. Okay, now, can it be plus or minus? No, it can't be plus or minus, because this is the length of a triangle, of the side of a triangle, and it has to be positive, okay? So Y is going to equal just simply 2 square roots of 2. If you go right to the positive, I'm going to be absolutely fine with that, because the situation we're dealing with a right triangle. It has to be positive, okay? All right, so now we know this opposite, right? This opposite leg. Okay, so what do we know now? We want to find tan of theta. Well, tan of theta is defined as the opposite leg over the adjacent leg. So we now know that the opposite leg is 2 square roots of 2. So this would be 2 square roots of 2 over 1. because the adjacent leg is 1. Okay. Now, what's 2 square roots of 2 over 1? Well, that's just simply 2 square roots of 2. Okay. And now we want to find sine of theta. Sine of theta is the opposite over the hypotenuse. So the opposite is 2 square roots of 2 over the hypotenuse, which is 3. And there's our two answers for tan theta and sine theta. Okay. All right, let's go to example number 3. For example 3, what we want to do is we want to find the measure of the angle indicated and then round to the nearest 0.001. Okay, so the angle indicated is this theta right here. Okay, now for angle theta, all right, let's identify which side's the hypotenuse. Well, it's the side that's 13 because that's the one that's opposite the 90-degree angle, right? So that's the hypotenuse. Okay, and then for this angle theta, the opposite of that would be this 7, right? So that's the opposite leg. Okay, so you have to, you're thinking about SOHCAH, TOA, so S-O-H, CAH, C-A-H, TOA, T-O-A, right? Okay, and which of those 3 trig functions deal with the opposite and the hypotenuse? Because that's what we have here, right? Okay, so that would be sine theta. Okay, so we know sine theta has to be 7 over 13. Okay, so the write-up is critical on this. You're showing your work, you're showing you understand the math, okay? So we know that from this, we know that sine of theta is equal to 7 over 13, okay? So this is where the inverse functions come in, okay? So we need to figure out, we need to have an inverse function that will undo sine theta. So because we're putting theta into sine, we need to put that into a function that will undo it and give us theta back out, right? And from last year, you guys know that that is sine inverse, okay? So what you have to do, and you need to show this. This step right here is important, and the next step is important, and the final answer is going to be important. Okay. So what we're going to do is we're going to take sine inverse of both sides. Okay. And so this needs to be a second line that you write, sine inverse, and we write with a little -1. Okay. Of sine theta is equal to, you're taking sine inverse of the left-hand side, and again, whatever you do to one side, you have to do to the other side. So we're going to take sine inverse of the right-hand side. So that'd be 7 over 13, okay? And sine inverse of sine theta, they are going to undo each other, and you're going to be left with theta is equal to sine inverse of 7 over 13. Now, we have no idea on what this is. Like you can't do it in your head, okay? There are tables that you'd pull up back in the day. Back when I was in school, you'd pull up a table and you'd look for this and you'd find what the approximation is. We're going to use our calculators, okay? Now, I'm going to do this 2 different ways. I'm going to do it once with the graphing calculator, and then I'm also going to do it for those of you who don't have graphing calculator. I'm going to do it using Desmos, okay? So I'm going to show you both ways on how to get this angle, okay? So we're going to go to our graphing calculator and Desmos next. All right, from our graphing calculator, what we have to do is we have to make sure that we're in degree mode. And this is all of the settings up here at the top of your graphing calculator screen, okay? And you look here and our calculator is in radian mode. So when you put a number in for sine and cosine, it thinks you're putting in a radian. That's not what we're doing here. We want to get degrees for this, okay? So we got to change the mode of our calculator. So we come over here and we press mode, and then we want to select degree. So it's the 4th line down, and we want to highlight degree instead of highlighting radian. So I'm going to come down using my arrow buttons, okay? I'm going to come over here on top of degree and press enter to highlight it. And now you notice it switched up here to degree now, right? So now we can press second quit, okay? And now because we're in degree mode, it will give us an answer that's in degrees. Otherwise, it would have given us an answer in radians, okay? And we really want this to be in degrees for right now, okay? All right, so we're going to do sine inverse, okay? Now, how you get sine inverse is you have to use the second feature, okay? Because it's the second function on this button, all right? So second sine for sine inverse, and then we're going to put in 7/13, okay? So I'm going to put in my fraction bar, and then 7 over 13. And we're going to press enter. and it gives us, and it won't give us the degree symbol, but we know because we're in degrees that this angle is in degrees. So it's 32.57 9. The 9 is going to cause this 8 to round up to 9. Again, I'm okay. If you write 32.578 and you just truncate, I'm fine with that. Or if you write 32.579, I'm fine with that too. I prefer you rounding because I think that's important, but it's okay if you don't. All right. Okay, so I'm going to show you how to do this on Desmos next. All right. Okay, so from Desmos, what we want to do is we want to go over here to the little wrench, okay? And this is the graph settings, okay? So we want to click on that. Okay, so right now, radians is highlighted down here. So we want it to be in degrees, okay? And I'm going to try this. I'm going to try reverse contrast. I think it's going to be a little bit easier for you guys to read this if I do the reverse contrast. So it's going to look like that. And I'm just going to slide this over a little bit so we get this a little bit bigger. Okay, so back to this show the keypad. We want to show that, okay? And then we want to select functions, okay? And what we want is sine inverse. So we're going to select this one, and then we're going to type in 7 divided by 13, okay? And I'm going to close my parenthesis. And there it gives it to us, right? It gives us the same number we got as the graphing calculator, 32.5789. The 9 will cause the 8 to round, okay? So let's go back and let's record this on our paper, okay? All right, so from our graphing calculator or Desmos, we have theta is approximately 32.579 degrees. Now, it's really important you write degrees because if you don't write it, it actually means 32.579 radians. So you got that's a point that I would take off on a test if you leave the degrees off because it's not the right answer. Okay, actually the whole answer would be wrong. Okay, because this angle is not 32.579 radians. It's 32.579 degrees. Okay. All right. One other thing that I want to talk about is there's another way that we write sine inverse. Okay. So there's another name for this because a lot of people don't like this little -1 because it looks like an exponent. Okay. And in this case, it doesn't mean exponent, but it looks like it, right? So a lot of people don't like this. So another way of saying this, sine, we have the function. This is a function in and of itself. So sine inverse of, let's say, x. Okay. Another name for this, okay, is arc sine of x, okay? We also have cosine inverse of x, and it's written like this, and that would be arc cosine of x, okay? And then we also have tan inverse of x, and that one's arc, A-R-C, tan of x. And these mean the same thing. So they're interchangeable. So I could have said arc sine, take arc sine of both sides, and it would be right. Okay. And then right here, we would have had theta is equal to arc sine of 7/13. And we would put that into our calculator. Okay. And so we just have to realize that these mean the same things. Okay. So some people will say this, some people will say this. I'm going to use it interchangeably so that you know both. Okay. Especially in the future. Okay. All right, so let's go to example number 4. So for example 4, we want to find the measure of the side indicated, and I want us to round to the nearest 0.001, okay? All right, so looking at this, all right, here's our right angle. So we know this side right here has to be the hypotenuse. We don't have this angle. Now we could find it, but that's just extra work, okay, we don't have to do. Not wrong if you do, okay? But this angle right here is 50 degrees. We do know that, right? So based on this 50-degree angle, this leg over here would be the opposite leg. Okay, so what we have here is we have the opposite, opposite, and we also have the hypotenuse. Okay, so what trig ratio deals with opposite and hypotenuse? And it would be the sine ratio. Okay, so we know sine of 50 degrees would have to be equal to this 6 over the x. And that's what's going to allow us to find what this x is, okay? We couldn't use Pythagorean theorem because we're missing this third side right here, right? So we need to know 2 of the 3 sides in order to do Pythagorean theorem. We don't have that, okay? So the other way to do it is with trig ratios, okay? So we know that sine of 50 degrees must be the same as 6 over x, okay? Now, how we solve this, some people put a 1 underneath the sine of 50 degrees. You're fine. That's not very sophisticated, but it will work and it's fine, okay? What I'd rather you understand to do is let's clear out our fractions, right? So let's multiply both sides by this x, okay? Because that's something I've taught you to do. X times sine of 50 degrees is equal to, and if we multiply this side by x, we'd be left with just 6, okay? So then what we would do next is we would, since this is x times sine of 50 degrees, we're going to divide both sides by sine of 50 degrees, okay? Now, this is the exact answer. So don't put sine of 50 degrees in your calculator until the very end, okay? Don't replace this with a decimal. That would be really, really wrong, okay? It's incorrect, okay? This is the exact answer. It's going to be x is exactly 6 divided by sine of 50 degrees. Okay, and that's the exact answer. Now, the problem is we don't know what that is, right? So we need to use a calculator to figure out, okay, what decimal is this, all right? Is this like 15? Is it 6? What is it, you know? Okay, so let's put this in our calculator, okay? And we're gonna put an approximate symbol here, okay? And so I'm gonna go back to my graphing calculator and put this in. All right, so from our graphing calculator, we're gonna press, we need the fraction bar, and then we're gonna type in 6 over, and then sine of 50, and press enter, and we get 7.8324. So the 4 will cause the 2 to stay 2, okay? So 7.832. So that's how you put in your graphing calculator. You would do, you know, something similar in Desmos. I'm not going to show you that. I think that's easy enough to do for you guys, okay? And we'll put that, and we'll go back and we'll record this on our paper. So on our paper, x would be 7.832. Okay. Now for example 5, we want to solve the triangle and we want to round all answers to the nearest 0.001. Okay, so what does it mean to solve the triangle? When we say solve the triangle, what we mean is we want to solve it and we want to find all of the sides and all of the angles, okay? All right, so what we have on this triangle, all we have is the 90-degree angle. Angle C is 90 degrees, okay? So that tells me something, you know, we know that this leg right here is 7 and this leg is 16. This leg we're going to need to, or not leg, this side we're going to need to find, and that's the hypotenuse because it's opposite the 90 degrees. Now, this is important. When a triangle is labeled like this point right here is capital C, right? So always, okay, the side that's opposite that is going to be labeled with lowercase letters, okay? So if this is capital C, then this side right here opposite is going to be lowercase c, okay? All right, then this 16 would be little b, and the 7 would be little a, lowercase a, and lowercase b for 16, okay? That's how we do this when it's labeled like this, all right? Okay, so how do we find c, okay? The way we can find c is we can use Pythagorean theorem, okay? So I know that 7 squared plus 16 squared is going to have to equal c squared. So 7 squared plus 16 squared is equal to c squared, okay? So 7 squared is 49 plus 16 squared, which is 256, is equal to c squared. And if you don't know 16 squared, I mean, you put that in your calculator, okay? 49 plus 256 is 305, which is equal to c squared, okay? We're gonna square root both sides. Now, here's where I'm gonna skip this, and I'm fine with you guys skipping this too, okay? If we square root both sides, we're talking about the positive one, right? So c has to be equal to the square root of 305. Okay, now once again, I don't know the size of that number, right? And I should say this, the hypotenuse always has to be the longest side because it's opposite the biggest angle, okay? So if this leg is 16, I know C is going to have to be bigger than 16, okay? All right, and so what is this approximately, okay? C is approximately, lowercase c is approximately 17.464. Okay, now I want to stress this with you. We cannot use this rounded value to find any other value. Okay, you cannot use 17.464 because C is not 17.464. This is just a number that's close to what C is. Okay, if you want to use anything, you're going to need to use the square root of 305. Okay, because that is the exact value of what C is. Okay, so don't use rounded values. Okay, it will be a mistake and people will take off points for that. Okay, you don't want to use rounded values when you don't have to. Okay, all right, so now we have this we have all three sides. Okay, and we want to find the angles. Okay, so if we look at angle A, okay, if we try to find angle A, and I'm going to label that one first. Okay, so finding angle A. Okay, and I'm going to show you a couple different ways of doing this. Okay, if we're talking about angle A right here, these two legs, I know, and those are nice numbers. They're not like square root of 305. So I want to use these to figure out angle A. Okay, so the 7 right here, if I'm at angle A, that's the opposite leg. Okay, so if I want to find this angle right here, right, this is the opposite leg, the 16 is the adjacent. So which trig functions or trig function deals with opposite and adjacent? And that would be tangent, okay? So we could say tan of angle A is equal to the opposite over the adjacent, which is 7 over 16. Okay, and then to undo this, we need to get capital A, right? We need to get angle A by itself. Okay, so we're going to take tan inverse of both sides. So I'd want to see this so tan inverse of tan A is equal to tan inverse of 7 over 16. This becomes A, or angle A, is equal to exactly tan inverse of 7 over 16. Okay, and that would mean A, capital A, is equal to, and then we're going to put that into our calculator. So I'm going to go to my graphing calculator and put that in. Okay, so I'm going to press, and I'm in degree mode. I'm always checking that. Okay, I want to press second tan for tan inverse. Okay, and then I'm going to put in 7 over 16. So alpha x, and then 7 over 13. So not 13, 16. And I'm going to press enter, and we get 23.6293. So this 3 will not cause the 9 to change. So it's 23.629 degrees. Okay. All right. So we're going to go back and record this on our paper. So what we got from the graphing calculator, that angle A was 23.629 degrees. Okay, now I'm gonna switch colors. I'm doing colors on purpose for you guys. Okay, all right. So now we're gonna find angle B. Okay, now I'm gonna talk about doing angle B a couple different ways. Okay, so finding angle B. Okay, I'm gonna write this: finding angle B. Okay, so now to find angle B, we're talking about this angle now, right? That's angle B in green. Okay, so now this is still my hypotenuse. I don't want to use that because it's not a very nice number. It's a square root number, okay? But this number right here, 16, that's a nice number, and 7. So I can use 16 and 7 for this one too. Now, what happens is it changes. The 16 now for angle B is the opposite, and the 7 now is the opposite leg, and the 7 is now the adjacent leg. Okay, so now I have tan of B is equal to the opposite, which is 16, over the adjacent leg, which is 7. And you're going to hear me say shorten it. I should be saying opposite leg and adjacent leg, but you're going to hear me say opposite and adjacent just to shorten it. Okay. Whenever you hear me say opposite and adjacent in terms of a right triangle, I'm talking about the opposite leg and the adjacent leg. Okay. All right. So to undo this, we're going to need to take the tan inverse of both sides. So tan inverse of tan B is equal to tan inverse of 16 over 7. These are going to undo each other, and you're going to be left with B is equal to tan inverse of 16 over 7. And I'm just going to give you the answer to this because I know you should know how to put this in your calculator at this point. Okay. So then B, if we went to our graphing calculator and put it in, B would come out to be 66.371 degrees. Okay. So, so what we were missing on this right triangle is we were missing angle A and we were missing angle B and we were missing the hypotenuse. Okay. So we had three pieces. We had the right angle 90, angle C, and we had the two legs, right? All right. Now, an alternative way of doing this. Okay. Once you find this, okay, we know the angles of a triangle, and I should write this alternate for finding angle B. Okay, so this just is an alternative way for finding it. Okay, because some of you may have been thinking this when you were watching this. Okay, and what we could have done is we know the angles of a triangle add up to 180 degrees. So an alternative way would be to do this. B is equal to 180 degrees minus the two angles that we know. Now, what are the two angles that we know? 90 degrees and then minus. Now, you don't want to write this one. Why? Because that's a rounded value. Actually, you know what? Let me get my red pen. I shouldn't have put equals here because that should be an approximation, okay? It actually should be because we rounded, right? Okay. All right. So it'd be 180 degrees minus 90 degrees minus, and we need to put this in, okay? So tan inverse of 7 over 16. Now, an alternative way we could do that, and it would give us the same answer as this one, okay? All right. Now, an alternative way is, well, if you have a right triangle, then the two acute angles are always have to add up to 90 degrees. So another way, a third way could be you just take 90 degrees minus tan inverse of 7 over 16. Okay. All right. And then you put that and would all this one would still give you the same answer that we got up here. Okay. Now you don't want to write this one because that's a rounded value. You don't want to put that one here. That's wrong. That'd be incorrect. Okay. I would mark it wrong. Okay. Okay. Because you have to, if you were doing some type of programming or anything, you could never use this because you can't use a rounded value. Okay. So I want you to know you can't use these rounded values. You got to use the actual value of it, which is this one. Okay. All right. Um, another way to do an alternative way to find angle A. Okay, so let me do that one. Okay, an alternative way to do angle A is we could have actually used the square root of 305. Okay, so then we would have done, let's say, let's do sine. Okay, so sine of A, and then let me write this alternative way. Alternate for finding angle A. Okay, we could have done sine of angle A. Now up here, if we're doing sine of angle A, that would be the 7, right? So sine of angle A would be 7 over, okay, the hypotenuse, right? And the hypotenuse, we wouldn't want to use this rounded value. We'd want to use the square root of 305. Okay, and then we would take sine inverse of both sides. Okay. And sine inverse of sine will undo each other, and you're going to be left with A is equal to sine inverse of 7 over the square root of 305. And that's not a final answer, so it's fine to leave the square root in the denominator. Okay. And then we put this into our calculator, and let me slide this up. I should have shown you that. Okay. Let me give you a moment to copy that down. Sorry, I didn't realize I went that low. Okay, so if we put this into our calculator, what we would get is the same answer as above. So we would get 23.629 degrees, okay? So just another way. The big thing on this one, though, you wouldn't want to use 17.464. That would cause this angle to be off a little bit, okay? It'd cause it to be slightly off, all right? Okay, let's go to example 6. Okay, so example 6 is again, solve the triangle, okay? And we want to round all answers to the nearest 0.001. Okay, so this time what I've given you is, here's my right angle right here. So this 5 must be the hypotenuse, okay? And I've given you this 53-degree angle and this 90-degree angle, right? Okay, so we could get angle B just by using geometry, right? The angles of a triangle always have to add up to 180 degrees. So we could start out by just saying, okay, B would have to equal 180 degrees minus 90 degrees minus 53 degrees, okay? And that would give you, if you put it in your calculator, that would give you an angle of 37 degrees, okay? So B is equal to 37 degrees, okay? Now, you could have also done it this way. You could have started out with just 90 degrees minus 53 degrees, okay? And that would be fine. You're going to see there's more than one way to do these problems, okay? All right, so now we know that this angle is exactly 37 degrees. So because we know it's exactly 37 degrees, we could actually use it to find other sides, okay? All right, so I'm gonna label this 37 degrees, okay? So you could use that angle, all right? Now here's the only thing that, my line of thinking, okay? If we had made a mistake here and we use the 37 degrees, now everything else is gonna be off, okay? So I would always try to use the pieces of information that's given in case you made a mistake in your calculations. All right. Okay. So this 53-degree angle right here, I'm going to use, and I'm going to use the 5. Okay. So if I'm going to use the 53-degree angle, these are my two legs. Okay. This leg that's opposite is the opposite leg. And I'm going to label that little a. Okay. And then I know this is another leg, right? And it's the adjacent leg. It's the one that's next to. Okay. So, and that's opposite angle B. So it's lowercase b, and that's the adjacent leg. Okay. All right. So I'm going to use my 53-degree angle, and I'm going to use the hypotenuse. Okay. Now, if we want to find this opposite side, okay, what trig ratio deals with opposite and hypotenuse? And it's the sine ratio. Okay. So I'm going to use sine. So sine of 53 degrees is equal to the opposite, which I'm calling A, over the hypotenuse, which is 5. Okay. So if I multiply both sides by 5, okay, I'll have what A is, right? So 5 sine of 53 degrees is equal to A, or A equals 5 sine of 53 degrees, okay? And then we could put this into our calculator, okay? And A would be about, and if we put that in our calculator, it would come out to be 3.993. Okay. And I put that in my calculator. Okay. Trust me. All right. I didn't do that in my head. All right. Okay. And then we need to find little b, right? So we found this side. Okay. It's exactly 5 sine of 53 degrees. It's approximately 3.993. Okay. To find this side right here, which we're labeling little b, right? It's the adjacent, and we want to still use the hypotenuse, okay? We wouldn't want to use this 3.993 because that's a rounded value, okay? We want to use the 5 and the 53-degree angles. So hypotenuse, angle, and the adjacent, right? What trig ratio deals with that? Well, it's cosine, right? So we have cosine of 53 degrees is equal to b, which I don't know, over my hypotenuse, which is 5. Again, multiply both sides by 5, and I would have b is equal to 5 cosine of 53 degrees, okay? And that would mean b is about, putting it into our calculator, okay, 3.009. Okay, so now, do we know all three side lengths? Yes. Do we know all three angles? Yes. We've solved the triangle, okay? Because that's what it is. That's what it means to solve the triangle, is you need to know all three sides and all three angles, okay? All right, and that's kind of a review of right triangle trig along with a few new things, okay? All right, so let me get the assignment sheet out and I'll tell you what's gonna be due, okay? Okay, so here's the assignment sheet. And what I want you to do is for today, which is the 17th of April, okay, I want you to do worksheet TF4 and the right triangle trigonometry, okay? Now, one thing I want to say is on yesterday's lesson, okay, we were doing degrees, degree decimal or degree minutes seconds. Remember doing that? Okay. If you don't have a calculator that will do that, please just skip those problems. It's quite all right if you skip those, because I gave you a couple to do today, okay? And if you just don't have a calculator, or if you just, even if you don't want to, it's no big deal. Those two problems, I'm not gonna say, oh, you didn't finish the homework, you didn't complete the homework because you didn't do those two. It's all right. Those are not crucial to all of the mathematics you're learning. It's not at all, okay? So don't even worry about it, okay? That was just something I wanted to show you that I've shown in years past, and we've had the graphing calculators in class to be able to do it, okay? All right, so let's just do TF4. This is gonna be due Tuesday, April 21st, because I'm always trying to give you 2 school days to complete assignments, okay? All right, you guys have a wonderful day, and I'll see you back Monday, the 20th, okay? All right, you guys take care. Bye.